Okay, let's see if we can tell the climate change story in pictures. We looked at this at the end of the last podcast, which is of a New York City power plant from the early 1900s when the industrial revolution started. Sorry. We were burning coal as the major fossil fuel, which was terrible, and we are still burning a lot of it, and there are countries which still get most of their power from coal. And excuse sorry about that. When you think about fossil fuels, whether it's gas, petrol, or natural gas, petrol, or coal, you can get estimates of how much more of it there is underground. Good Lord, I'm having real cough fit here, so I'm not going to stop and start again because this is how life works. It's very humid here and I get dehydrated when I speak and get excited. I need to drink water. So you have to figure out how much coal there is and how much natural gas there is, how much petrol or gasoline or oil there is, so that if we keep on digging them up and burning them, how long can we go? This is the calculation of the energy companies. They say, don't worry, we have enough fossil fuels to last us for a long time. So you have to think, what do they mean? Do they mean climate change is not happening? Do they mean fossil fuels are not bad, and so on and so forth? So you can turn it around and say there is enough fossil fuel for us to transition to renewable energy, so we don't have to shut down anything. We burn just enough fossil fuel, try to burn as little coal as possible since it's the worst polluting of the fossil fuels, and quickly deploy renewable energies and improve efficiencies, bring in electric vehicles and so on and so forth, and solve the climate change problem. So you cannot quit fossil fuel immediately, especially many growing countries like India and China, because they don't have clean fossil fuels. Natural gas is considered cleaner fossil fuel, and they haven't deployed enough renewable energies. And remember, the accumulated CO2 is not mostly because of them, it's mostly because of the rich countries. So how to solve this problem has to be thought of in many different ways. So keep solving, but keep burning fossil fuel till you can get to a safe point. And the other aspect is that coal is now very unhealthy. It's becoming economically unviable. It means even if you produce coal, US tends to produce coal because it's employment, it's politics. Politicians win in coal towns and coal states by saying they support coal, but they export the coal. So the other issue you have to think about it is, if India is burning coal but it is getting coal from US, then who is responsible for the emissions? Is it India because it is burning the coal, or is it US because it is producing the coal? So you have to have these complicated calculations which you are too young to do, but the more you are aware of the complications, the less you will think there is some magic solution to this climate change problem, the energy problem, and the fossil fuel problem. So be patient, keep working on solutions, keep learning more and more, and keep making progress for yourself. Here is the view of Reed Glacier in Glacier Bay National Park, Alaska, which shows pieces of glacier here with a ship cruising along, maybe taking tourists or watching what's happening. And you can see, as you remember, glaciers can flow, so they flow down the slopes into the ocean or the estuary and water is warming, so it's breaking the glacier, and the glacier is retreating and melting quickly, and so on and so forth. So there is evidence everywhere showing that we are melting glaciers and that sea level is rising in a global mean. But just like we talked about the coffee cup, if I take my teacup and do it this way, then the level will not be the same everywhere, and since Earth is rotating and the winds are blowing, sea level will not rise everywhere, but it is dangerous where it does rise. So glaciers are a very clear indicators, and we can use satellites and drones and aircrafts and people to see how fast they are retreating or moving back, right? There is snow falling on top sometimes and the glacier is trying to grow, but it's melting so fast that this glacier can keep retreating. There are many details that we won't get to talk about. Here is a view of Reed Glacier in Glacier Bay National Park in 2013. This is in 1956 and you can see it has all but disappeared. Right, so much of it has melted away, and you can see these slopes are now completely devoid of glaciers. So we are doing things, and here is a polar bear that wants that waits for Hudson Bay to freeze over in 2007, and as we said before, it used to start freezing in October and November, but now even December it may not be freezing, and the polar bear is desperately trying to walk around on broken and thin sea ice and try to find food. And here is a picture of teenagers in an Alaskan village hopping on to melting sheets of ice. They may know this is not good news. They may have seen in their lifetime that it used to be solid ice here, but now the ice is melting away and is broken into pieces. That's not good news, right? Because remember again the albedo. If this was all one continuous ice sheet, then the albedo would have been higher, energy would have been reflected, temperatures would have been colder, and the melting would have taken longer. But once it begins to break into pieces, the water is exposed, which is not at all as bright as the ice, so its albedo is much lower. It absorbs more energy and reflects very little, so water will keep getting warmer faster and the ice will melt faster, and then you have a feedback vicious circle as we called it before. Here is where Charles David Keeling started measuring CO2 first in the 1950s in Mauna Loa, Hawaii, as owned by National Oceanic and Atmospheric Administration of the US, and the altitude or elevation here is 3,300 meters or some 11,500 feet, so it is high up, and if you measure at one place it indicates very well what is the concentration of CO2 in the northern hemisphere, because CO2 is very inert and it goes around and get mixed around and represents the concentration. Here is the South Pole Observatory, which is measuring many things including CO2. Antarctica, which has lots of glaciers, is losing glaciers in some places and growing glaciers in other places because the southern ocean is sitting around and getting warm and making the atmosphere warm and humid and producing snow in some places, but melting the glacier. And the ice shelf, remember the glacier flowing onto the ocean as shelf, is getting broken into pieces and being melted. Here is the March for Science in Washington DC in 2017. More and more people, you can see all the young people here, these are all young people with a couple of older people, all aware of climate science, and science is not silence. You have to think, if you stand up for a cause and you want to fight for climate action, you also have to do your part and learn more, find solutions, and consume less, waste less, and be careful with the environment, right? Now we have Earth Day in April, the first Earth Day event in the front page of the New York Daily News in 1970, when the Republican President Richard Nixon was in power, and many things happened after that, but we still celebrate Earth Day every year. We have World Oceans Day, we have World Environment Day, and so on. It's not that we have to think about these things only once a year, but each year we should be reminded of how much work remains to be done. Here is a woman paddling down a flooded road during the aftermath of Hurricane Harvey in Texas in 2017. The part of Texas that is sticking out into the Gulf of Mexico. Houston got some 3 feet of rain in, I think, 2 or 3 days. With the warmer ocean, cyclones can get strong very fast because the energy comes from the ocean, and warmer the ocean, more the energy, and then more rainfall can fall with the hurricane because now warm ocean is supplying more moisture. Okay, and here is a young Kenyan boy standing on a dried up riverbed in 2009. We talked about droughts in Kenya and famines in Somalia and Ethiopia and Djibouti and so on. This East Africa became dry a few million years ago and remains fairly dry, and few years of missing rain can make it really dry. Here is raging wildfire in California. As we said, California is climatologically a dry place, which means it gets very little rain. Population has grown, wealth has grown, people are living near woods and creating more opportunities for wildfire as well. This is a bleached coral reef in the Great Barrier Reef, which gets hit very hard by natural climate variability such as El Nino. If you don't know what that means, don't worry about it. If you want to learn, I have many podcasts on it. If you're old enough to know what it is, you may know already that El Nino can cause warming and coral bleaching and so on across the world. Workman at a natural gas plant in 1946. I might have displaced it a little bit, but now the idea is, can we actually stop taking out oil, gas and coal from the ground, free money sitting there, and stop burning them because you can make so much money? But if renewable power becomes so cheap, then there may be no market for fossil fuel, in which case nobody will dig it up, right? So imagine what you can do. Make renewable power very efficient and cheap and grow it everywhere, in your school, in your house, in your backyard. Tell your town, tell your parents, tell your teachers, ask your teachers, and maybe you can keep growing renewables so fast, like this wind turbine spinning behind a field of solar panels in Germany. There are countries now in Europe which are producing most, if not all, of their energy from renewables. Okay, but they will still be importing things and exporting things where fossil fuel is still involved. Okay, so you have to worry about that. Let's read about the timelines of climate change in the next podcast and make that the last podcast of this chapter. There are many more photos. You can find them on World Wildlife Fund, on National Geographic, on NOAA's website, on European Space Agency, on Australian Bureau of Meteorological Society, on India's meteorology department. Everybody is capturing the impacts of climate change and the devastation it can cause, and also deployments of solar energy and wind energy and so on. So please learn and see and read and think of what you can do and not be depressed or anxious about the future. So see you in the next podcast, which should wrap up this book on What is Climate Change by Gail Herman. See you.